What is boiling exactly? We usually think of it as being when you raise the temperature of a liquid that it gets to a point where it starts bubbling and then the particles of the liquid are able to escape into the atmosphere. And we usually think that that needs heat to do that, but that's not necessarily true. You can demonstrate that using a syringe. We're going to use this to create a vacuum and some water. And this water is actually pretty hot. I was boiling it a couple minutes ago, but it's not hot enough to boil. You can see it's not boiling. So if we cover this part of the syringe here so that no air can get in, we're going to pull this down and we're going to create a vacuum inside. And as I do that, you can see bubbles start to form in the liquid. So it is actually boiling, and then if I let go, it'll go back to normal pressure. So what's going on? Well, the water molecules in here, they want to escape. The water has a certain pressure that it needs to allow vapor to escape. It's called the vapor pressure. But right now we also have atmospheric pressure pushing down on here, 14.7 pounds per square inch roughly at sea level. So the air pressure is actually pushing down on the water, and it's kind of bottling in the vapor and not allowing it to escape. So the less air pressure there is, the easier it is for the water molecules to turn into vapor and escape. So that's how we were able to use the syringe to create a partial vacuum and to cause the water to boil. The higher up you are in altitude, the easier it is to boil water. So this is why recipes for cooking change depending on how high up you are, because the water or whatever it is you're cooking, it can't hold as much heat before it starts to turn into vapor and boil. In fact, there's a story in Darwin's diary from the Beagle, that Darwin evolution guy, and he talks about one time when they were on their expedition and they were above 10,000 feet. He didn't know exactly how high, and he talks about how they tried boiling these potatoes for hours and hours and hours and they wouldn't get soft, and then they gave up and they tried boiling them the next day and they still wouldn't get soft. So they were so high up that you actually couldn't cook something, which is pretty wild. So as you go up, you may have heard that water will boil when it is exposed to a vacuum like space. And that's true, but it's not because the water is hot, it's because room temperature water will boil in a vacuum. That just means it's losing its vapor. So I just wanted to illustrate this because these concepts become our basic physical intuitions about how the world works, but there's actually a lot of things that are outside of our experience that we might not have ever seen that will show us that our intuitions aren't correct. So I wanted to show that, and that actually goes back to the PV equals nRT, which I had discussed before in a different video showing how ambient air pressure can actually crush a can, and how there's actually about 3 full-size adult elephants worth of weight pressing on me right now. So we can see, again, pressure, P for pressure, V for volume. We multiply those together, and then equals N, which is that's the amount of stuff we have. N is the number of molecules. R is the constant, so we don't have to worry about that. And then that times the temperature. So what you can actually see is we lower the pressure, equal signs mean balance. So we have to balance this side with that side. If this changes, if this goes down, this has to go down. And since you can't change the number of molecules, that's set, and you can't change the volume, as the pressure goes down, the temperature goes down. So we find that water will boil actually at lower temperatures than it does at sea level. So that's an interesting little tidbit there, and a fun little science demonstration that you can do at home. And like I said, this water is not cold. I was just boiling this earlier, so it's pretty warm. You want to do this, you want to have an adult do this. It is definitely warm to the touch, but let's see. It's been sitting out here for about 5 minutes, but it's still boiling. Pretty cool. All right, thanks, and we'll see you next time. Bye.